A predator is an organism that kills and eats another organism. And the prey is the organism that gets eaten by the predator. We're able to look at the populations of predators and prey and see that the two are interrelated. They're dependent on each other. And we can express that in a predator-prey graph. So we're not interested in individual predators and prey. We're interested in the population of a species, so the number of organisms of a particular species in any area, and how those populations are dependent on each other. So I'm going to show you how to do that in a graph, a population graph, a predator-prey graph. So we're looking at populations, so on our y-axis we're actually going to look at the population, the number of organisms, and on the x-axis we're looking at time. Now the time we're looking at is over years, maybe decades, because we're talking about populations and they need to increase and decrease based on births and deaths, etc. So we're talking about years, but that depends on the type of species. I want you to see that there's a relationship between the predator population and the prey population. So firstly, I'm going to start by drawing the start of the prey graph. So what we see with both species is that the population cycles. They have booms and busts. The population increases and then decreases. So when conditions are ideal for the prey, there's plenty of food, there's good environmental conditions for them to be able to reproduce, their population increases. But then it gets to a point where it can't increase anymore. It gets to what we call its carrying capacity, because there's not enough food to sustain the population. Maybe there's the introduction of disease, or it's because there's so many prey organisms to eat, it attracts the predators. So the predator population then comes along and starts to increase to feed on those prey. And of course, if they're feeding on the prey, it's going to mean that the prey population is then going to decrease. So if the prey population decreases, that means that the same thing's going to happen with the predator population. It's also going to decrease. And if the predator population decreases, well, that's the ideal time for the prey population to increase again. And if the prey population increases, well, that's going to be the ideal time for more predators to come along or reproduce and increase the predator population. So then, if there's an increased predator population, then that means we're going to have a decrease in prey population, and then we're going to have the same pattern happen with the predators, and it's going to continue to cycle like that. Now, I'm just going to go ahead and label this. This is the prey, and this is our predator population. Now there's a couple of observations I want you to make. Firstly, they both populations cycle and have the same pattern of boom and bust. So they both cycle up and down and boom and bust. The next thing I want you to see is that there's more prey than there are predators. And of course the reason for that is that energy flow through the ecosystem is inefficient. So an ecosystem must have more prey organisms than predator organisms. And the third thing I want you to see is the curve for the predators actually lags behind the prey, because its population is dependent on the population of the prey. So the predator curve lags behind. And they're the three things that you need to remember about the predator-prey curves. I guess one final thing is that this is really, I guess, an ideal or idealistic model, because of course when you think about a food web, no one species really just predates another species. They always, in nearly every case, it's more complex than that, with different predators and different prey. So it's probably rare to be able to do this exact pattern.